Hi friends, today we are discussing about Elgamal cryptography. Actually, it is a asymmetric key cryptography, or we can say it is public key cryptography. That means different keys are used for the encryption and decryption. Consider here two processes we are having. Actually, in general, that is digital signature generation. For that we are using a private key. Next part is verification. For that we are using a public key. So different keys are using here. So we are calling it as asymmetric key cryptography. So in this Elgamal, actually three steps, major steps are there. First we have to generate the key. Next we have to do the encryption. Next decryption. That means actually through a channel, one sender is there, another part receiver is there. Sender is sending something to the receiver. So whatever the message is sent by the sender, that has to be received at the receiver end. So we are checking here, okay, the plain text which is sent by the sender is received at the correctly received at the receiver end or not. Okay, so for that, first let us generate the key. For key generation, namely 5 steps we are having. First thing, here everything about assuming the values. Okay, so we are selecting a large prime number. It is P. So here we are taking a number as 11. Okay, next we are selecting a decryption key. It is also called as a private key. It is denoted by small letter d. That is also we are assuming as 3. Next we are again the next part of the encryption key. Okay, E1, that is the next part. That is also we are assuming as E1 equal to 2. So next again the third part of the encryption we have to find out. For that we are having a formula. That is third part of encryption key is E2. E2 can be calculated with the help of this formula, E1 power D mod P. Here already for the P we are having the value 11 and D we are assuming a value as 3. For E1 we are assuming the value as 2. Now we are applying all these values into the formula. 2 power 3 mod 11, that is 8 mod 11, will get the answer as 8. Now our E2 is generated. Okay, E2 is generated as 8. So actually public key is nothing but the combination of E1, E2 and P and the private key D. Okay, here the public key is nothing but E1, we already guessed the value, that is 2. E2 just now we have calculated, that is 8, and our P is 11, right? So this is the combination of the public key. Now the next phase, that is the second phase, is encryption. Here again we are assuming some other values. First thing we are selecting a random integer, that is R. Here we are taking a value as 4. Next we have to calculate the C1 value, ciphertext 1. Okay, that is C1. So again there is a formula we are using here, E1 power R mod P. Okay, so we know the value of E1, that is 2. R, that is 4, P we already taken as 11. Now we are applying all the values here. 2 power 4 mod 11, 16 mod 11, we are getting a value as 5, that is our C1. Similarly, we have to find the C2, ciphertext 2 value. Everything is a combination. Okay, for C2 again we are having another one formula. PT is nothing but plain text into E2 raised to R, E2 power R mod P. This is a formula to calculate C2. So okay, here we are assuming the plain text. Whatever the message we are communicating to the receiver is 7. Consider I am sending a value 7. Okay, 7 into E2 is 8, R we have taken as 4. So 8 power 4 mod, our P value is 11. So the value after calculation will be getting this much value, 28672 mod 11. So applying the values, again we will get the value C2 equal to 6. So the ciphertext combination, that is the fourth step, C1 comma C2. So we will be getting 5 comma 6 is the ciphertext value. So value has been sent to the receiver. Okay, now let us see at the receiver end. Again the receiver will be receiving a coded value that they have to decode. So only they can read the original message, right? So at the decryption end, again they are applying a formula. See, every formula you have to by heart, okay? So plain text is equal to C2 into C1 power D whole raised to minus 1 the whole mod P. This is the formula. So C2 we know the value 6, C1 we know the value 5, D we know the value 3, whole raised to minus 1 mod 11. P value we know that is 11. Right. Now 6 into 5 power 3 is nothing but 125 raised to minus 1 mod 11. Now first of all we have to find out this inverse value, right? To find out the inverse of 125, what we have to do means there is another one formula actually. 125 into x, some value we are taking x, okay? That mod 11 will give us 1. So for this x, whatever value we are applying, it can be 1, 2, 3, etc. So whatever value we are applying to the x, which will lead to the answer 1, that has to be taken. That is the inverse of 125 power minus 1, right? So here we are checking with 1, checking with 2, but if we are checking the x value with 3, 125 into 3 mod 11, 375 mod 11 will be getting, this answer will be giving us 1. So our 125 raised to minus 1 will be the 3 value, okay? X value will be 3. Next what we are doing, see, we are applying the same formula, this one. C2 into C1 power D raised to minus 1 mod P. So the formula again we are applying. Here we have stopped, right? From this point again I am coming back. 6 into 125 raised to minus 1 mod 11. So this value we have got 3. 6 into 3 mod 11, what we will be getting? 18 mod 11. See, the answer 7 we are receiving at the receiver end. So both at the sender end we are sending a value 7, at the receiver end also we are receiving the value with 7. So for verification, this Elgamal cryptography we are using. This is one kind of algorithm. Thank you.